A warm good morning to everyone. We are from Aditya College of Engineering and Technology from the Department of Computer Science and Engineering with the specialization of Internet of Things. We have chosen our final year project as Sign Language to Voice Conversion and Home Automation using hand gesture recognition with Arduino. So, as a team we have developed this project. My name is Sripriya and I am Machine Learning Engineer.
I am Umesh and my role is hardware and IoT integration.
My name is Vishal and I am a software developer.
Okay, my name is Gowtham. My role is testing engineer.
This is the complete setup of our project. Let me explain the circuit. All the ground pins from the various components are connected together and linked to the voltage regulator, which steps down the battery voltage. And the main components of the project are Arduino Uno R4 acts as a main controller of the entire system. GSM module used for communication, and fan and light serves as an output devices. Magnetic switch relays used to safe control the fan and lights. Voltage regulator used to step down the voltage. Additionally, we are using laptop camera to detect real world hand gestures, allowing for gesture based control, and the laptop speaker is used as an audio output to provide sound alerts.
This project, I am the machine learning engineer. Gesture recognition pipeline that empowers individuals with speech or mobility impairments to communicate essential needs using hand gestures. So these gestures are recognized in real time using the computer vision and deep learning and then converted into spoken sentences using the text to speech. Additionally, the gesture can also trigger actions on an Arduino Uno R4 Wi-Fi for a system automation. The system comprises three core modules. First one is the data collection, second one is the model training, and the third one is real-time inference. In the first phase, that is this collect_data.py phase, I have developed a custom data acquisition tool using MediaPipe and OpenCV to capture hand landmarks for 31 unique gestures. Each gesture is recorded with 100 samples consisting of 84 features, 21 landmarks per hand, both the hands. So this data is saved in a structured format, laying a solid foundation for model training. So in the second phase, which is the train_model.py, that one I have designed and trained a multi-layer perception, that is MLP, using TensorFlow Keras. The feed-forward neural network includes 4 hidden layers with ReLU activation and drop-off regularization, followed by a softmax output layer for classifying 32 gesture classes. The input features were normalized and gesture labels were encoded using label encoder. The model was trained over 50 epochs using the Adam optimizer and saved as gesture_model.h5. For deployment, the final phase, that is test_.py, brings the model into real-time application. It loads the trained MLP model, processes live webcam input to extract landmarks and predicts gestures using the model. So I implemented prediction smoothing using confidence thresholds and history buffers to reduce misclassifications. Detected gestures are spoken aloud using PyTT-SX3 and communicated to the Arduino. The system is multi-threaded to ensure smooth camera input, processing, display, and the audio feedback. So we have used a deep neural network, that is DNN architecture, because it is highly suitable for structured numerical data like hand landmarks. It performs better than traditional ML models on this kind of data and is much faster and more efficient than CNN, that is convolutional neural networks, or RNNs, which are unnecessarily complex for our use case. The model is accurate, lightweight, and ideal for real-time gesture classification in assistive systems. So we have used a multi-layer perceptron, that is MLP architecture, for designing this project. That is, it is a type of deep neural network specifically suited for structured numerical input like hand landmark coordinates. The MLP processes 84 input features and classifies them into 31 gesture categories. It was chosen for its efficiency, accuracy, and suitability for real-time systems. So, an MLP is a class of feed-forward artificial neural network, which consists of an input layer and one or more hidden layers and an output layer. Each layer in an MLP is fully connected to the next, and the non-linear activation functions like the ReLU, rectified linear unit, are used in the hidden layers. So, in my project, the input layer has 84 features, means landmarks, and there are 4 hidden layers with ReLU and dropout. This Arduino program serves as the hardware and communication interface for the hand gesture recognition system. It receives recognized gesture commands from the Python-based machine learning model via serial communication and performs actions accordingly. Using the Wi-Fi S3 and Arduino HTTP client libraries, the Arduino Uno R4 Wi-Fi connects to the specified Wi-Fi network and can send SMS alerts to a registered mobile number through an API. When specific emergency gestures like I need a doctor or I am in a danger are detected, the Arduino immediately sends the predefined messages using a secure API key and message template. Additionally, the program controls GPIO pins to switch on and off connected devices such as light, which is connected to the pin number 13, and fan, which is connected to the pin number 12, based on gestures like turn on the lights, turn off the fan. The loop constantly listens for commands, processes them, and triggers the corresponding output. So, as the machine learning engineer, I ensured accurate gesture prediction and reliable integration with the Arduino to enable real-time voice feedback automation and emergency response, creating a responsive and accessible assistive solution. So, in summary, I would like to tell that I handle the entire end-to-end machine learning pipeline starting from collecting the raw data to designing, training, and deploying the model in a real-time system. I also integrated the ML component with hardware and voice interfaces to build an intelligent, responsive, and accessible solution for people with disabilities. So, this project highlights how machine learning can be applied to solve real-world problems and bring meaningful improvements to a quality of life. This is the confusion matrix which is generated for our project. And this is the classification report which has also been generated for our project. Thank you very much.
Hello, I am Vishal. As the software developer, I collaborate with the machine learning engineer to bring the gesture recognition into fully functional real-time application. While ML engineer focused on data collection, data training, and gesture prediction, I developed the supporting software that allows the system to interact smoothly with user and hardware. I implemented voice feedback using PYTT-SX3, enabling the system to speak out recognized gesture and handle serial communication with Arduino to control devices like light and send emergency messages. I also designed a simple graphic interface using Tkinter to display the current gesture and confidence level. Throughout the project, I ensured that the code was clean, modular, and efficient, helping the system run reliable in real-time conditions.
Hi, I'm testing engineer of this project. As a testing engineer, I developed comprehensive test plans and test cases to validate the functionality, performance, and reliability of both hardware and software components, and also execute tests systematically, documenting results and identifying any defects or areas for implementing in the systems, and also conduct user acceptance testing to gather feedback and ensure the system meets their needs and acceptance. Thank you.
Turn on the lights. Turn on the lights. Turn on the fan. assistance.